So we are super excited today because this is something that we've been talking about for a while here at the CaDC to really bring a whole bunch of experts together to share what's going on with ET, ETO, all of those great things. And what I'm hoping to do today is to pull up my screen now that all of our panelists have gone through it. What I want to do is share, if I can. Yeah, there we go. Our agenda for today. So we're going to do a quick welcome, intro to who CaDC is. Then we're going to introduce all of our speakers, let them share all of their great information that we're all hungry to understand. And then we'll have a few announcements at the end. We are recording this session. It will be made publicly available along with the PowerPoints shortly after this presentation. So who is the California Data Collaborative? We are a fiscally sponsored nonprofit, and we are staffed by several data experts, but we are governed by our members who are all water agencies, and you can see our members here. We've just added one this week, and so we are really here to provide a lot of different resources to the water industry at large. And we do this by acting as a cooperative. So our members identify different programs and problems that they want to solve together. And then we help illustrate, bring those to life, whether that's through some type of software, a research that we're working on, a webinar, or even ideas that are brought forward in our annual flagship summit. So that's what our members benefit from, as well as many of you here who are non-members who are joining us. So our membership includes collaboration in lots of different forms. We have a software system for water retailers that helps them visualize their water consumption data so they can make data-driven decisions. We do lots of different customized projects for our members to help them use their data. And then we work with different institutions and other nonprofits to do research. But I'm really excited today because, like I was saying, this is something that a lot of our members have been struggling with. They want to know more information. And so we're able to provide lots of different insights that will hopefully help you understand the different data solutions that are out there for developing water budgets for landscapes. So we've got Amanda Miner, who's going to speak first, and then she's going to kind of like overlay what we're going to talk about. Then we have Bekele from DWR, who's going to talk about CIMIS. And then we have Ben Slick with HydroPoint, talking about some hyperlocal data sources. And then we have Mona Bina and Lindsay from Multinigal Water District, and they're going to focus on how these different data sources impact how they've developed landscape budgets for their customers. So what we're trying to answer today is, what is ET? What is reference evapotranspiration? Different sources of precipitation, and how do we use that for water management, specifically for developing landscape water budgets? And how does regional versus hyperlocal data differ, and does it even matter? What data sources are available, and how do we access them? And how does different data, how does that differ in accuracy, resolution, and function? And then lastly, how do these sources impact local water suppliers who are trying to develop these budgets? So I'm not going to read all of everyone's bios, but the presentation will be available right after this. Amanda is a certified GIS professional. She works with Envirocom Corporation, and we're thrilled to have you. Thank you so much for being here. She's going to tag team this with our newest addition, who let us know today that he was available. Another meeting got canceled for him, so he was able to attend. We're super excited to also welcome Forrest Melton from NASA, who's going to share a little bit about OpenET. And then we have Bekele Temesgen from DWR, who's going to focus on CIMIS and all of those questions that we've been hearing from members in the water industry at large. Ben Slick is going to go next with HydroPoint. He's been doing a lot of work on this hyperlocal ET data and really going to share some insights into what data sources they're using and how they're using it across the state. And then Lindsay and Mona Bina are going to tag team as well, and talk about their specific projects for Molten Nickell Water District. So you're welcome to type into the Q&A if you have questions. If you want to use the chat function, please feel free to do that. We will take questions at the end of the entire presentation. So as people are speaking, feel free to use that chat or Q&A function, whatever you're most comfortable with. So with that, I'm going to hand it over to Amanda. Thank you so much.
Oh. Where did my... Sorry,
We're just seeing your drive screen.
There we go.
Yeah, there we go. Okay.
Put the pad on it. Okay, there we go. All right. So I'm just going to do an overview for this whole thing. I'm not an expert on evapotranspiration or water budgets. I've just been coming at this from the data perspective and what's out there. The subject of evapotranspiration can be definitely outlaid a lot better by some of the experts on this panel. But anyway, here's an overview and sort of the experience that I've had with some of the data out there. So what is evapotranspiration? It's the loss of water from the soil, evaporation from the soil surface, and transpiration from the leaves of the plants that grow on it. And there's a lot of things that affect that rate: solar radiation, atmospheric vapor pressure, temperature, wind, soil moisture. I lifted this information from the CIMIS site, so you know, I'm not an expert. I'm going to use other people's words a lot. So why does it matter? So if potential evapotranspiration is greater than the actual precipitation, the soil is going to dry out unless those conditions stabilize. And why that matters is because of the irrigation that needs to be used to keep the plants alive. So what is ETO? I know there's been a lot of confusion about ETO, ETR, ETC, I think is out there. So ETO was generated because it's very difficult to estimate ET under all of the different conditions and climates and weather conditions. So researchers developed the reference ET, and reference ET basically that's used as a reference plant. It's a term used to describe the evapotranspiration rate of that reference plant in inches or millimeters, and grass is the closest thing to sort of urban and city village areas where people live rather than agricultural areas. So that's probably the closest thing, and so that's used a lot to talk about water budgets. And again, I listed this from the, apologies to the next speaker because I listed a lot of this from the CIMIS information. I sort of wanted to know what are all of the data inputs that get put into a water budget from a scientific perspective. So the equation given on the CIMIS site is irrigation plus precipitation plus capillary rise minus ETO minus depopulation minus runoff. Easy, right? And so CIMIS has done amazing things, and with probably not that much budget. And they've provided us with rainfall information and evapotranspiration data. Some of the other inputs in that equation are not available. So if we were to try to do a water budget model, we would have to develop that other data ourselves, I believe. Open to being corrected on that though. So yeah, basically the runoff and depopulation, according to CIMIS, can be estimated using the soil properties and slope values. It seems that the dew formation and capillary rise are difficult to measure and can be ignored in a lot of cases. Users need to estimate other factors such as plant type, rooting, and plant density. So what is it that we're measuring? And again, I'm not super clear on all of the regulation, but from my conversations with Kim, I understand that we're measuring service area water budget, where the resolution is district-wide, like this, and budget-based rates, where the resolution is at the individual parcel level, and we're trying to get this indoor, outdoor, and inefficient budget question answered. So the question I have is, do we have the right data to answer that question at the resolution that the data is available? And that's kind of my perspective coming into this. So data types, what data can be used to measure evapotranspiration? And I'm talking about like the raw inputs, not how it's calculated or anything. We can use Earth observation data. We can use aerial imagery. They have different spatial resolutions and temporal resolution, which basically just how often do we get the new data, right? Remote sensors, which I believe is going to be discussed, so I won't go into that, but very, very high resolution because it's right there. But I mean, you can submit data every second if you want to collect that much data. So it is very powerful. However, the distribution in California seems to be quite uneven because the focus being agriculture initially, at least. So the spatial imagery resolution for drone imagery and the temporal resolution as well is very, very high. But is it cost effective to do drone flights for everything? Probably not. But it's an option, so I threw it in there. So the data in spatial CIMIS, for instance, has a resolution of 2 kilometers. That means every pixel in that data has one value, and it's 2 kilometers by 2 kilometers, right? So at the district level, that's fine because you can aggregate this and get a general idea of what you have as an overall value. But then when you get to parcel level water budgets, can you use the same data? I guess the hint I put here is, should every parcel in this 2 by 2 kilometer square have the exact same value? And so there's the limitation of using that resolution data as an input. It's fairly clear, I think. So, and then another thing I come across a lot, parcel data. Parcels are often misaligned, especially in high terrain areas, because they're not survey grade and they're not, then they don't account for terrain variation. So you'll often see that they're moved slightly off of the parcel. And so if you were calculating a water budget, and I actually saw this before the session, I was looking at a video from one of the other water districts where they've used this method, and they have a system where customers can come back and kind of have their lot reevaluated because it doesn't really represent, right? So in this particular case over here, you can see that I did this was a while ago, did a near infrared just to pull the vegetation value. But look at the alignment of, so this guy is paying for this guy is paying for this guy. Do you see what I'm saying with the shift? It's not, might make some inequitable cases, right? So other people paying for others. And then here's another example, like this road is clearly meant to be on this lot, got vegetation on it. Houses often are crossing 2 lots because it can be really off. So what data sources and tools are out there? So we've got CIMIS, OpenET, potential for custom analysis. I don't know if there are other options out there. These are the ones I know about. Custom analysis, quite technical, as some of the following slides of folks who are going to talk after me will indicate. You can use combinations of these things, but I'm going to let the person after me speak to CIMIS, but I did want to point out that there is a feature service of those ETA areas that you can pull into your GIS. And then OpenET recently, on October 3rd, released their API, which allows for integration with applications too. So, and one thing to bear in mind is a lot of these things were initially created for agriculture, and now we have the challenge of how do we interpret that for water district. So with that being said, I'm going to have Forrest, who knows far more about OpenET than I do, come and speak to these next couple of slides. Take it away, Forrest.
Sure. Thank you, Amanda. So Amanda had asked me to join briefly and talk a little bit about OpenET and what its strengths and limitations were, especially for urban and suburban landscaping. Short answer, I would say that for quantification of ET from landscaping in urban and suburban areas, probably not yet suitable for use, or there would be large uncertainty. In addition, and I'm hoping Bekela can comment on this when he speaks, my understanding is that the model, the Water Efficient Landscape Ordinance specifically references Appendix B, the Water Efficient Landscape Workshop, and water efficient landscape worksheet, and that would be the recommended tool for quantifying estimated total water use, as well as the maximum allowed water allowance. So I'm hoping, Michaela, that you can speak a little bit more to those tools in your remarks. But I will take a moment to explain what OpenET is. It was developed to make it much, much easier to get access to satellite-based information on evapotranspiration at the scale of individual agricultural fields, as well as to quantify evapotranspiration at the scale of watersheds or river basins. We have not yet assessed the accuracy of OpenET data for urban and suburban landscapes, though we have assessed accuracy for agricultural and natural land cover types across the West. We do use an ensemble of models that include both thermal infrared and reflectance-based approaches that we use to quantify ET, primarily from Landsat data currently. And the spatial resolution is 30 meters by 30 meters, or about a quarter acre per pixel. And we can provide data daily, monthly, and annual timescales from 2016 to present. And hopefully soon we'll be working with the California Department of Water Resources to extend that data record back to 2001. And we're updating data with month by month with approximately 1 month latency for the monthly data. So OpenET, in terms of applications for urban and suburban landscaping, for larger parks and golf courses, it should be reasonable. I'd say for areas of about 5 acres or larger, or any park that's larger than, say, roughly 150 meters in the smallest dimension, should be a reasonable approximation for total ET. Keep in mind that OpenET currently quantifies the ET from all sources of water, including irrigation and precipitation. Focus for OpenET was initially on agricultural lands, natural land cover types, and we wouldn't really recommend it for areas that are smaller than 100 meters by 100 meters currently, or for areas that have very small areas of vegetation intermixed with impervious surface areas, such as driveways, rooftops, any asphalt or concrete surface. And then, as Amanda was just mentioning, there is now an API for folks who are interested in pulling data in for larger areas. So that automated application programming interface is designed to make it easy to retrieve data and integrate it with other water management applications and water data information systems. Next slide. Where we're heading for OpenET, we are currently, one of the most frequent questions we're asked is, how can we use OpenET for urban and suburban areas? So that is something we are working on. The OpenET science team is evaluating a couple of different approaches for trying to improve quantification of ET from landscaping. It is a really hard problem. That said, incorporation of data from Sentinel-2 and some of the airborne data from the National Agricultural Imagery Program, combined with data sources like CIMMYS and Spatial CIMMYS in California, does offer promise. But there are some significant challenges, even in terms of defining the total area of irrigated landscaping, including artificial turf, shadows from buildings and trees, trying to partition ET from tree canopies versus understory vegetation. And making this an even harder problem, there are very, very few ground-based data sets in urban and suburban areas that we can use to benchmark the accuracy of new approaches and evaluate model performance and see what's actually resulting in a meaningful improvement. That said, we'll continue to work on this problem. If folks are interested in collaborating with us or have good data sets that could serve as benchmarks for evaluating new models and new approaches to using satellite and airborne data to quantify ET, would definitely be interested in talking further. And then the final thing I'll flag is that, again, OpenET includes ET from all sources. So if we just want to look at ET from irrigation, we also need to subtract off effective precipitation. And I'll note that the water efficient landscape ordinance does include a recommended equation for calculating effective precipitation in urban areas. And the OpenET team is also working on some automated methods to do this. But it will be important to separate out the ET from effective precipitation and the ET from applied water. For more information on OpenET, please do take a look at openetdata.org. You can sign up for the Data Explorer and the API, which is now publicly available. Happy to answer more questions during discussion. Back to you, Amanda. Thank you.
All right, thank you very much. Yeah, so I guess some of the questions I had going through this, and I think you just addressed a couple of them actually, Forrest, about, if you guys are you're sort of collaborating with CIMMYS, what is, for spatial CIMMYS, what is the potential for utilizing some of those higher resolution data sets like Sentinel-2 to integrate, or if this is even appropriate, could CIMMYS provide some of those other inputs to that water budget formula? Again, I don't know if the goal is to try to get that exact water balance budget, but if it is, are there any plans among you guys, among your groups? And I know, Forrest, you and I have talked about a couple of ideas you've had and approaches, but does the benefit, I guess this is the question I have, does the benefit of everyone using the same standardized data outweigh the challenge of producing it? And do we need to find a way to standardize the approach? Because the way that we do things to make it meaningful, that regulatory expectation kind of has to align with what the data can actually tell us. And obviously, the more that we can rely on metered data, the better, because that can tell us things. But we're talking about including some of this other data that is more abstract into that calculation. So, or do we wait for OpenET to do some of this urban stuff on the roadmap? And Forrest already spoke to what it could be used for in the meantime. Or do we go rogue, do drone stuff, or use proprietary solutions? And we're going to hear about HydroPoint in a little while. But Forrest, do you want to speak to a couple of the things we spoke about a little bit earlier about some other approaches? Do you have any thoughts?
And over lunch there, just before this webinar, I was reading up on the water efficient landscape ordinance. And so I think at this time, I'd like to hear from Bekele in particular about his recommendations and description of the water efficient landscape worksheet, which is specifically referenced by the ordinance as the tool to be used to help quantify these key terms, including the estimated total water use, as well as the maximum allowed water allowance. So after Bekele's comments during the panel discussion, happy to come back to the Q&A and offer thoughts if needed.
Thank you. So that's it from me. Not sure how helpful this was, but it's an introduction to some of the challenges from a user's perspective, I guess, trying to integrate and implement.
Awesome. Thank you so much, Amanda and Forrest. Really appreciate it.
How do I stop?
Yeah, there should be if you look on the bar that has all of the info, you should be able to stop share. Let's see if I can do it on my end.
It tells me I can share again, but not stop there. Interesting. Oh, there we go. Found it. Okay. Sorry, too many things open.
No worries. So with that, we're going to transition to CIMMYS. And Bekele, if you want to share your screen.
All right. Can you hear me?
Yes.
Okay. All right. You see my screen as well?
Not yet. So there should be a separate little button that says after share screen.
Okay, hold on one moment.
No worries. We can see your screen, but we see your calendar.
I got it.
There we go.
Yeah,
we can see it. No worries.
All right. Appreciate the opportunity to speak at the California Data Collaborative today. My name is Bekele Thomas Ken. I manage land and the water use section within the water use efficiency branch at DWR. I think I had the opportunity to discuss ET, ETO, and effective precipitation with many of you during the outdoor water use standard development. I was managing that program. and also the landscape area measurement. We had several work group meetings to make a determination for the standards, and we submitted our recommendation to the State Water Board, and they are working on the regulations right now. So with that, these are some of the questions that were move this thing out of the way. That were given to me. I think these were collected from folks who wanted to understand what data should we use to calculate landscape water budgets, and what is actual versus reference ET. For some of you, that would be very simple. For others, I think they need to understand what the difference is when we say ETO and just ET, and the spatial scale as well. I know Amanda spoke about parcel level. This legislation is not entirely about parcel level water budget. It is rather mostly at this service area level. It doesn't mean at parcel level information is not important. It is important because it is a parcel level data that we aggregate into service area level, and I will be describing how we do that. Our ET and the precipitation data used to calculate. I will show you the equations that we use for that. What is the resolution of CIMS data? I think Amanda and DeForest covered most of my presentations for me. It is a 2-kilometer resolution for spatial CIMS, and there is also station data that I will be talking about. Is there a way to overlay data with GIS layer? Yeah, for those interested, there is a contact information from the CIMS team that I will be sharing with you. You can contact them if you want to do it yourself. But for this legislative directive, though, I don't think you need to do it because we have done it for you, and I'll show you where you can get that information. But if you just want to play with the data, there is a way that you can overlay the CIMS data. Is CIMS using OpenET? I think this is one of the questions Amanda and DeForest covered it, so I don't need to go there. But I just want to mention on that point, it is actually the other way around. OpenET is using CIMS ETO information from spatial CIMS in many ways, because the satellite overpass is once every 16 days. And to fill the gap in between, they use ETO or reference evapotranspiration from CIMS. So we have a good relationship there. So in 2018, 2 legislative bills were enacted, and Senate Bill 606 and Assembly Bill 1668, and it required the department, DWR at least, to provide or identify data regarding the unique local conditions to support the calculation of urban water use objective. So what is urban water use objective? It is defined in that legislation as an estimate of aggregate efficient water use for the previous year based on adopted water use efficiency standards and the local service area characteristics for that year. So if you guys are submitting your report in 2024, the data must be from 2023. If you are submitting in 2023, the data must come from 2022, and so on. So what does the efficient urban water use objective is calculated from all of this? Indoor residential water use. There are standards that were developed that I'm sure everybody is aware of at this point. There is a GPCD that changes over time. You need your population, and then you multiply that GPCD by population and by 365 days within a year to get your indoor residential water use. Outdoor residential water use, we'll be talking about the data that goes into the calculation of outdoor residential water use in this presentation. And also for CII, for commercial, industrial, and institutional water use, with dedicated irrigation meters. It is the same kind of approach as the residential. I will be covering that part, the data that goes into that as well. And water losses. I don't agree there is an efficient water loss, but that is how it is stated in the legislation, efficient water losses. I do believe there are standards that were developed by the State Water Board, so I am not covering the data that goes into that here. And there's an estimated water use in accordance with variances. There is quite a lot of variances, but my focus will be on ag variance in this presentation because we provide the data that goes into the calculation of ag variances for those of you who have urban agriculture in your service area. So for most of outdoor water use estimates, the efficient outdoor water use, EOWU, that is, in gallons is calculated using this basic equation, whether it is for CII, residential, even the ag, the numbers might vary, but this is the basic equation. ETO is reference evapotranspiration in inches. PEF, it might be, you might find it different in terms of the abbreviation here, but in this case, it is effective precipitation. LA stands for irrigable landscape area in this context, and then ETF is sort of an ET adjustment factor at the service area level. In the Muelo that Forrest was referring to, it is ETAF. Just to distinguish it from that, we call it ETF here. I think the Water Board calls it landscape efficiency factor. It means it's the same thing, but a different abbreviation here. This 0.62 is a unit conversion factor to get this water use in terms of gallons. These are inches, and the landscape area is square feet, and so to convert that is a unit conversion factor. So the data that you guys would get from DWR for your reporting is reference evapotranspiration. There are two kinds of reference evapotranspiration, that is annual, and this is mostly used to calculate outdoor water use, efficient outdoor water use. Annual means January 1st to December 31st for those who report on calendar basis. And there is also, for those who report based on fiscal calendar, it will be July 1st through June 30. I think the Water Board is working on that in the regulation. I don't know if it will still be both calendar based and the fiscal based, because the Water Board, I think in the regulation, they have only fiscal. I don't know about that, but in any case, we will be, from DWR's point of view, we will be presenting both data. The seasonal one is mostly for ag variances, seasonal ETO and the seasonal effective precipitation. That means it is only for the season when we have actual irrigation. We don't include every ETO value throughout the year from the previous year. The same is true for effective precipitation. You will get one annual and one seasonal. And they will also be talking about irrigable landscape area for residential. That is something you have already received. I'll tell you where in that report you can find your landscape area. And then DWR, although we were not directed by the legislation, we are working on providing the CII landscape area to the agencies. It may not be available for the current reporting period. For many of you, even next year, it may not be available because it's going to take some time. But ultimately, you will be getting that CII. Mind you, this is not the final one. After receiving this data, you need to work on it because it requires identification of dedicated irrigation meters. we don't have information about that. We cannot tell it from remotely sensitive information. So you still need to do some work, but we'll provide you the basics for you to do that. And ultimately, evapotranspiration factor mainly for the ag variance. We already have the ETF in the regulation itself. We made recommendation, but for the ag, we will be presenting that information. The data can be found at this link. Some of you already might have looked at the TWR recommendation. It is posted here. The data will be at the very end of that page where it says tools and the data. You just expand that. It is not there yet, mind you, but we'll be putting the in about 3 weeks or so. We'll just put in the final touch to most of the data that we post. Now, to the basics, I think most of this is covered earlier. What is evapotranspiration? As you can see here, as the sun energy hits the surface, the water that is on the leaf surface and on the soil would evaporate as E. And also, when plants absorb water through the roots and through the stomach, they lose as transpiration. The combination of that is evapotranspiration. People have been working on accurately estimating evapotranspiration for centuries. We are still at it. Currently, the Perman-Montes equation is used worldwide as a standard method for estimation of reference evapotranspiration rather, but we're not there yet. But what factors affect ET? The weather affects ET. These are mentioned earlier: solar radiation, air temperature, relative humidity. The nature of the plant itself, its type, height, density, and so on affect evapotranspiration. And even management factors affect ET. So under all this combination of factors, it would be almost impossible or not practical, if possible, it's not practical to set up instrumentation under all these conditions. So scientists developed what we call reference evapotranspiration. In this case, you will have a standardized surface, such as the one that you see on the right-hand side. It is a well-irrigated grass field. This is one of the semi-station locations. The grass is mowed at certain height, and through research, it has been established what parameters to use to calculate evapotranspiration from such surface. Once you have that for a specific crop type, you will use what is known as crop coefficient. And then for landscape, it is called landscape coefficient. And this KC and the KL are established through research again. And so your ET from a specific plant type is calculated as the ETO that we talked about multiplied by these factors. And this estimate, ETC, would give you the plant requirement, the plant water requirement. The plants need that amount of water. But that is not what you apply. You need to apply more because of irrigation efficiency. So irrigation efficiency would be factored in. The ETF that we talked about earlier is sort of a ratio of this K factor divided by irrigation efficiency. So where does the ETO and the come from? Where does the DWR get the ETO value? I think most of you know, and I think Forrest and Amanda spoke about CIMIS, the department in collaboration with UC Davis in the early 1980s established a network of automated weather stations that you see on the left-hand side. Currently, we have about 150 of them scattered. Some of you have a station within your service area, others do not. So what that distribution tells us is there are a lot of spatial data gaps for ETO. The more station we get, the better, because in the early 2000s, this is when I started working with CIMIS at that time. We looked at this and tried to find a way to fill the data gap, the spatial data gap, and we collaborated with UC Davis remote sensing team at that time, and we came up with spatial signals. This is the antenna that we use to capture data from the GOES satellite. That would give us the solar radiation that I mentioned earlier, which contributes to about 60 or more % of ETO estimation, because it is the ultimate energy that breaks down the water molecule, right? The rest of the parameters contribute as well, but solar radiation contributes more. So we get solar radiation from the satellite, and then for the rest of the parameters, we kind of interpolate between similar stations. So the accuracy of the data, the interpolated data, depends on the density of the similar stations on the ground. So if you don't have a similar station locally, your estimate would still be better than not having anything, but it could be better if you have a similar station. I will be talking about what you need to install a similar station in your service area. So the spatial semis works by coming up with different layers of these parameters. Again, as the RS is from the satellite, and the rest of them are from interpolations. And we use the Perman-Montes equation to daily generate a spatial map like this one of ETO. That information is available on the SIM site, but again, for this legislative reporting, for the urban water use objective calculation and this reporting, you don't need to do that because we have done that already. So, in case you are interested in having a SIM station, in the past, DWR I think purchased about 3 dozen stations initially in the 1980s, and then it was only what we call cooperators. It could be agencies and individuals and so on that purchase the equipment. But right now, we are willing to buy these stations if you can provide the site for us. What are these siting requirements? The ideal fetch size is about 600 feet of irrigated cool season grass pasture in every direction. I know this is a lot, but I think we kind of understand the difficulty of getting that amount of land. So we work with agencies. But something that folks should know is, as the fetch size, fetch is the distance from the station location to the edges of the grass or alfalfa surface, mostly grass. As the fetch size gets smaller, accuracy of ETO estimation decreases. So the larger the fetch, the better will be the data. Again, since it is difficult to find the ideal fetch size, especially in California, we do accept reduced fetch size to some extent, about 300 feet or so in every direction. Again, another requirement, if the site is grazed, fencing is required, and these are other siting requirements that you can discuss with the SIMS team as you contact them and figure out if you can install SIMS station. Some of the responsibility of a cooperator is, we have to have a land use agreement that authorizes GWR to install the equipment on the property, and there are some maintenances that are required, such as irrigating the field and the mowing grasses as needed, working with SIMS team, communicating some issues that may arise to DWR. And again, some of cooperators might be required to buy the station, but at this point, we might get some resources to purchase those ourselves. If you needed to contact SIMS team, these are the guys that would make this happen for you. There are other regional folks too, but these are the headquarters staff that can work with you so that you can coordinate with the local groups and install a new SIMS station in your area. Now, about effective precipitation, AB 1668 directs DWR to incorporate precipitation data and the climate data. I think we kind of discussed this during the previous meetings with the work group for outdoor irrigation budget. Effective precipitation is nothing but is a portion of the total precipitation which becomes available for plant growth. As rain falls, some of it get lost as runoff, and the other part would go to deep percolation, and some might even evaporate back, and the remaining amount which enters the soil and is within the root zone is what we call effective precipitation. There are a lot of factors that affect the effective precipitation, such as slope, land cover type, and the intensity and the duration of rainfall. But for this purpose, we are using a water balance model from DWR that is called CaDC. It is California simulation of evapotranspiration of applied water. That is the model that we're using. That is a model that we've been using for California Water Plan update for those of you who read that publication. Because of these uncertainties, there is a lot of factor going into it. Because of all that uncertainties, we decided to cap effective precipitation at 25%. So that means if the model output gives us about effective precipitation to be about 75% of the total precipitation, we don't accept that. We only cap it at 25%. So we'll be presenting annual and the seasonal effective precipitation to the water supply. A little bit about calcimeter. I don't know if this thing is blocking you guys' view here, but excuse me. The calcimeter is a daily soil water balance model. Again, it is initially designed for agricultural crops, but in this context, it was applied to urban settings by assuming the surface is covered with green lawns around cool season grass, just like reference evapotranspiration. And that is why it was adjusted to 25%, one of the reasons. The input parameters that go into the calcimeter is the precipitation data from PRISM. This is a model from Oregon State University that is really nationally recognized and used by many researchers. Of course, spatial sims that we talked about, and the soil data comes from USCDS Sargo, and the crop information that comes from the DWR crop survey information. And this is the modeling concept, evapotranspiration, irrigation, rain, everything goes into it, and ultimately we get effective precipitation out of it. Now, I know a lot of folks have expressed concern that precipitation is happening in the winter and during the summer season when we do irrigation, there is no precipitation. But let me show you the concept. This is a daily, this is a monthly. During the winter season where there is a lot of irrigation, effective precipitation is so minor, so small amount, because there is no ET at that moment. The ET is very low. So as you can see here, most of it is either going to runoff or deep percolation. The monthly one shows very clearly here. Again, this is only the model output. This bar is only the model output, but the actual effective precipitation is about 25% if the ratio is more than 25%. For example, this one right here, this is in April, about 40 millimeters, right? This is effective precipitation. The brown one is effective precipitation, by the way. It will be reduced further because it is definitely more than 25%. So it would probably be right around here. So all of it is not going to be effective precipitation at that point. It's only a small amount. Now, how do we get ETO, a single number for a service area? a single number. That's the average number that we get it. Now, from spatial semis, we get ETO at each one of these grid points, right? And some of the grid points are not covered by the service area boundaries. What we'll do is we are going to use a weighting average approach, whereby the ETO is multiplied by area within each grid, and then it is divided by the sum total of the area to get a weighted average ETO and a weighted average effective precipitation. So that if there is more ET on one side of your service area and less, it would be weighted, and then you get that one number. Ultimately, you will use that number to calculate your efficient outdoor water use. So you don't have to worry about some part of your ET being different, the microclimate being different from other parts of your service area. I think I covered this one, the annual ETO and effective precipitation and the seasonal. Again, the annual is either January 1st to December or July 1st to June if it is based on fiscal. And this one is used to calculate efficient outdoor water use for both residential and the CII. If there are two agencies adjacent to each other, this value will be the same because it is annual. But in this case, for the seasonal, even if they are close to each other, the values might be different because it depends on what kind of crops are grown in each one. If there is a crop that is grown for a long time, that means the ETO is going to be more in the service area. So this value, don't be surprised if you see different values for two agencies that are adjacent to each other. Again, this is only if you have urban agriculture and you want to get that credit based on the criteria that were put forward by the State Water Board to get the variance, the ag variance. So how do we get the ag variance? The same equations that we talked about earlier: seasonal ETO, seasonal effective precipitation, and the seasonal ETF. So we have a land use map from DWR that we now publish almost annually. It used to be very infrequently in the past, but now using we are working with Land IQ. We get the land use map almost annually. We use that information to estimate for each supplier that has urban agriculture. We use the crop information from DWR. We calculate for each crop type and a supplier service area using the specific start and the end date. This is important. And then a weighted average seasonal ETO and effective precipitation are calculated. So that is how we come up with seasonal ETO and effective precipitation. For ETF as well, we use the same information. This is a land use map, for example. And for each crop, we get the CaDC and the irrigation efficiency values from a calcimeter database. Initially, these values were derived either from FAO published CaDC tables, some of you might know, or UC cooperative extension data points. That is how the calcimeter database was constructed. And then what happens is the average CaDC and the irrigation efficiency values are calculated. And this graph shows, I'm sorry about that. I didn't mean to do that. So CaDC for each crop this is a standard CaDC curve. As plants grow more and more land is covered, the CaDC value increases linearly and it kind of stabilizes and it declines. So what we do is for each crop type within your service area, we come up with an average throughout the year. And then based on the areas of each crop type, we calculate the weighted average CaDC and the irrigation efficiency values. And ultimately we calculate ETF because ETF is crop coefficient divided by irrigation efficiency. The last data piece is landscape area, irrigable landscape area. the legislation directed us to provide each arbitrary water supplier with data regarding the area of residential irrigable lands. So we provided the landscape area measurement or LAM data to all of you. The provided data has irrigable irrigated, irrigable not irrigated, and the not irrigable classification. The way you need to calculate your irrigable landscape area is you take the irrigable irrigated and add to it 20% of the irrigable not irrigated. That has been established, and at least up to 2027, the regulation, draft regulation by the Water Board also accepts that. Beyond that, they want to eliminate that 20% of INI totally. I'm not sure where that ends up to be. But for this application, though, you get your II and then you add 20% to it. Now, where exactly is the irrigable area in the delivered LAM data? All of this is the data that you must have received from DWR. I know it can be overwhelming and it can be confusing. So that is why I wanted to clarify. There are 3 places that you get the same kind of information, but it will give you the IIs, INIs, and NI. One is a PDF report. This is deleted because it has the name of the agency, but it is with agency name and the SAM number to it. It's a report that came with your entire data. That is one point. Another one is it says BUID summary. For every one of you, it says BUID summary. It is an Excel spreadsheet. And there is a GIS layer also for those of you who have a GIS. But remember, these 3 data sources will give you the same thing, but it is a matter of choosing which one to use. So let us look at each one of them, how they appear. So this is a report itself. It looks like this. This is the first page of the report. For most of you, table 3 contains that data, that information for landscape area. You have your irrigable irrigated area, you have irrigable not irrigated. But for those of you who had a follow-up discussion with DWR and your landscape area is reanalyzed, it will be table 1. If there has been adjustment, very few of you, but most of you have it as table 3. So between table 1 and the table 3, those are where you get this information. But the format looks like that. So your irrigable landscape area from this one using the formula that I showed you earlier is this 103 million plus 20% of 28 million. You just come up with that area. The same is true here. And the BUID summary CSV report also shows you at the very end of that page, I mean that spreadsheet, you see total II, total INI, and the total NI. So you just scroll down and you get the sum of each of these columns to get the aggregate numbers for II, INI, and NI. And again, if you have a GIS shape file, you can simply get the statistics on that. And better yet, there is also an AOI. There, if you bring up, it will give you a summary from the B layer. Whatever you do in this case, do not open the AUID summary. That is wrong because that gives you data by parcel, but some of the parcels are stuck on top of another by design, so the numbers will be inflated. So those are not the correct ones. This is a flattened area BUID, so this is the one that you're expected to use. And then we also will be providing, this is not delivered yet, another table that lists all of the agencies together, all 399, I believe, at this point. And they will be providing horse coral areas, ag areas, pool areas, total INI. That will be published on our website very soon. So this is an additional information. If you don't want to deal with the previous reports and everything, you can just come over here and pick up your numbers from here. for the irrigable irrigated, irrigable not irrigated, and then do the calculations. Again, this is the same thing for annual and the seasonal ETO effective precipitation in the ETF. There will be 2 additional Excel files that we will be adding to the same site website that I showed you earlier for ETO and effective precipitation, as well as seasonal, annual. This is annual and then seasonal values as well. Now, I want to mention this. I don't want to go into details on this one. I don't know how much time I have, but there is a language in the legislation that says if interested suppliers can use an alternative source of data, if that alternative source are shown to be as accurate as or more accurate than data provided by the department. So this is a key. It has to be as good as DWR's data or better. So the way to prove that is by submitting a request to DWR according to the legislation, and I think on the regulation, the Water Board will also want to see it. So in the guidelines and the methodologies that we provided, Chapter 9 really indicates how you verify the use of your own data, alternative data. And I will just use a couple of examples here. This is not everything, but there are certain criteria. So for example, for ETO, you have to describe why your alternative data meets or exceeds the quality of DWR data. You have to describe the methodology that you use to estimate ETO. Is it station data, remote sensing, or how did you do that? You have to indicate the source of that data. It has to be certified because if somebody or a consultant did it for you, they have to certify that it is a good quality data. There has to be some public process where the public has an opportunity to review alternative data, and general manager has to sign onto that request and submit it to GWR. This is highlighted because the Water Board also wants to get that report according to the draft regulation. And the same is true for effective precipitation, the same kind of criteria, and there has to be some public processes, and the general manager has to sign into it as well. So that will be my presentation, and I will wait for questions and answers. Thank you.
Thank you so much. That was very informative, and I know it's going to help a lot of folks out there. We're going to save the questions for the end, but there are some questions for you in the Q&A and the chat. So maybe if you want to take a look at those, and then after Lindsay and Mobina get a chance to speak, we'll open those questions up. Thank you so much.
Thank you. So you want me to answer now or just
We'll
wait?
answer, yeah, at the end. We'll let everybody speak first.
Okay, I'm trying to stretch here.
There you go.
All right, thank you.
So we're gonna kick it off or kick it over to Ben Slick with HydroPoint. Are you able to share your screen?
There we go.
There you go.
Good afternoon, everybody. Thank you very much for the time. As an overview, HydroPoint Data Systems is a 20-year-old company headquartered in Petaluma, California. Our sole focus in life is water use efficiency. Our first product was a smart irrigation control device that was novel in its time. It sent an evaporation message over a wireless network, and then software in the controller programmed with soil type, plant type, sprinkler type, slope, sun exposure, et cetera, made scheduling decisions about how to properly apply water. So global weather with local site intelligence providing an efficient conservation benefit to stop dry weather runoff as well as properly irrigate plant material. The product has been in market for 20 years, is widely deployed. We have over 45,000 network subscribed customers using that data. We'll focus on that weather data in this presentation, but know that we're using it commercially nationwide for our own business. So accurate weather, why even bother? Well, knowing when not to irrigate matters. The point of weather data is to inform what nature took away. And the only reason we irrigate at all is we grow things in a market that wouldn't ordinarily sustain them without supplemental water. ET has been described is the environment robbing the soil of moisture through factors, and then plants themselves drawing water through the roots and sweating it off their leaves. Irrigation replaces that lost soil moisture. It's difficult to measure evapotranspiration directly at several levels, but we've got models, as we've currently discussed. There are 35 different models. For sub-Saharan Africa, crop ET was really just temperature only, and Dan Hargraves built that back, I don't know, in the 50s and 60s after the Dust Bowl. Today, we use Penman-Monteith as our model, which is a great landscape-specific model for irrigation. The ET equation isn't something most gardeners know how to apply, and so therefore that's what our computers and our science is meant to help with, is to properly calculate water lost from these environmental factors so that they properly put water back. Note that the Penman-Monteith equation does not account for precipitation, and so part of the HydroPoint offering is we also monitor Doppler, and we amend following days ET with accumulated precipitation from Doppler. So in order to do ET modeling at all, you need good weather data, and those come from weather stations. And as was previously discussed by our friend at CIMMYS, you got to site them in a proper place, on turf, in open air, so they're available to wind and solar radiation. And you don't want to site them on a roof or in a paved area. You don't want to enclose them. These are things that will increase the readings and therefore increase the irrigation use. So why are we different? Well, HydroPoint uses a climate model, and it's informed by terrestrial weather stations, but we are first and foremost a customer of NOAA. And NOAA has a weather research and forecasting model called WRF, which is a high resolution model that grids the North American continent into, like a checkerboard, 0.6 square miles or 1 square kilometer grids. And so what we start our day with is we download the model from NOAA, and then all day long, weather data from terrestrial stations, anywhere from 40 to 60,000 stations, report in data. And that data streams into our climate center, where we have a full-time climate scientist whose job is to look at anomaly, look at data that doesn't make sense, sensors that are offline, what have you. And at the end of the day, we've accumulated enough data to know exactly how much water has evaporated for any square kilometer anywhere in North America. The National Weather Service is a huge customer of this. NOAA has public funding from the government to continue this. The WSR-88D is one of the most powerful and advanced surveillance and Doppler systems in the world. So we're relying on industry-grade data that is commercially available for government purposes, for research purposes, crop ag extension and soil and science purposes. We specifically just focus on what we use for commercial irrigation. So how do we do it? Well, we again start our day with this model, and that model uses big environmental factors like solar radiation off the Earth's crust, jet stream, heat island effect of buildings, vegetative indices, all these different things. Then when the weather data starts pouring in, much like water going into a Jell-O mold, it fills in the cracks with informed information about actual readings. And we get data from all kinds of different places. At the end, we model this with a balanced physics model. And then that includes all kinds of localization categories. We've got a high computing infrastructure. We're hosted at AWS. And so this has got all the computer power we need to manage huge amounts of data. And the systems are obviously redundant because they're backed up, and there's multiple data centers with ABS that we're connected to. So what all this means is, there are 423,900 square kilometers in the state of California alone. And we're calculating a daily evaporation number for each and every one of those. So there are 145 CIMMYS stations. And so, as was earlier explained, the effectiveness of their interpolated data improves greatly when there's a greater number of stations to be interpolated through. Our system doesn't rely on interpolation. Rather, we're calculating this from a model level at a global level down. So water challenges, we see that if you've got a single weather station, the data can vary in accuracy by over 250%. So depending on where the station is located and where a microzone is where someone's irrigating, there could be a huge discrepancy, and i.e. fairness in who gets informed what on their water budgets. So in our hometown of Petaluma, we took a snapshot of this where there's a station that generated a 1/4 inch of evaporation, but then the downtown, the coastal differences in calculation through our model showed huge differential. So a customer, being billed an adjusted water budget formula would have very different calculus in, this type of model. So when you think about this grid, every of these square kilometers get a daily number of evapotranspiration based on these variables. And so how again can these vary? We've done studies on historical ET for water agencies. We've done the differentiated numbers for ET values within microzones within a water agency shapefile. And then we also, by the way, calculate the evapotranspiration number for the grid that a CIMA station sits in. And we cross-check our calculation every day with what the CIMA station reported. So it's a way of double-checking accuracy on what we know are to be calibrated stations. There are days when some stations might go offline or their sensor might be offline, but generally, it's a great way for us to ensure the accuracy of our model. Another great example here in Rancho, California Water District, we had a huge difference in residential versus commercial accounts, a bunch of ag accounts, 846 unique microzones, and then some adjacent to microzone boundaries. So how do you map that? So when you look at this, the ET could vary more than 1.5 inches monthly and almost 4 inches annually for the stations that were either close or far away from the CIMA station. And then compared to CIMAS, during a different period of the year, again, similar differences. So these variances are things that we track every day. Several customers in the water agency world buy our data and use it in their billing systems to inform their water budget rate structures. And we post that data to them on a daily basis. So they're getting daily microzone specific ET through an FTP site. They come and pull that data out on a routine into their systems, and then every day concatenate those files until on a monthly basis, they know how to inform the water budget for that site. So a great example will be our next presenter, but Molten Niguel, in the bottom left picture where they're located in the world, middle, all the grids, all the microzones that make up data around them and within them. And then the chart on the right shows you specific microzone numbers for each of those things that we calculate a daily evaporation number for. So I won't make my presentation longer or harder. It's really, we are a service and we're commercially using this data. It's highly accurate. It's reliable to the tune of being in the cash registers of our customers. And, we base a business around this. So it's core critical for us to keep it up and running. And we've been doing it for 20 years and we'll continue to do so. Thank you for that. And I'll take questions after the break is over. Thank you.
Thanks, Ben. Really appreciate that. So next, I'm going to kick it over to Lindsay and Mona Bina.
Hey y'all, just trying to get my screen shared. Are we good?
Yep, we're good. Can hear you, can see
Lindsay,
you.
good to see you, Lindsay.
Hi, good to see you as well. Thanks for having us on. I'm Lindsay Stubik. I'm our Sustainable Resources Officer here at Molten Niguel, and Mona Bina is going to join us a little bit later. I'll go ahead and introduce you, Mona Bina. She's our Senior Water Resources Analyst, PhD economist, brilliant person who has done a lot of the analytics here. I'm just introducing a lot of it. But just giving a overview of some of the work that the district has done, since we've got a lot of experience working with ET. And we've embarked on a series of analysis that I'm excited to share about what we have found for our service area. And I'm hoping that the folks that are listening in today can, hear about some of the stuff that the district has come up with and maybe see if it applies for their service area as well. And I'll try to get to the next screen. Okay, I don't know how to get rid of this. Sorry, Kim. I think this is in the way, but there we go. So is that working? Is that all right?
Yeah, it's all good. Mhm.
Okay, perfect. All right. So just a little bit about Molten-Nagel. We provide drinking water, wastewater, and recycled water services to 170,000 people in South Orange County, have about 55,000 accounts, and we have a 7-member board of directors. We've received a lot of recognition really from our local and statewide and nationally for our different innovation and water efficiency programs, as well as our workforce culture. And we really pride ourselves on having the lowest average bill in South Orange County. And we have a water budget-based rate structure and have had one since 2011. And also interestingly, we import 100% of our water, or of our drinking water. So a little bit about our water resources and demand management program. So as I stated, we import about 100% of our potable supplies from either the Colorado River or the State Water Project through from Metropolitan. And about 25% of our annual demands are met with recycled water. The district was an early pioneer in recycled water, and we've had recycled water since the 1960s, first serving it to golf courses and then master planning our community to serve recycled water for irrigation purposes. And that's how we've been able to achieve that really nice offset number of 25%. Because we do import 100% of our supplies, it is an expensive source of water. So we've really emphasized demand management and water efficiency. We tell folks that it's not about using less, it's about wasting less. And so we really try to provide resources and programs to help our customers not only just reduce water, but really like reduce their bills overall. And the district's been it's been a very effective approach. We've reduced our demands by 40% since 2007. And it's just been a pretty phenomenal program. I will say that I can attribute a lot of those savings to the district's implementation of water budget-based rates. And I'll get to this formula in a minute, but just a little background on the water budget. So every one of our residential customers, commercial customers, and dedicated irrigation customers receives a monthly water budget. For potable water sources, we provide customers with a 0.7 landscaping factor. It's like the equivalent of the landscape efficiency factor. Our recycled water customers get a 0.8. And areas that are like high traffic, like sports fields, or what I guess you would call like functional, not just functional turf, but functional areas, get a 1.0. And so we've had these factors since 2011. Our residential customers will get an indoor and an outdoor budget, but our dedicated irrigation folks are getting this particular outdoor water budget. So this water budget should look familiar. It looks very similar to what a lot of water agencies are going to encounter when they start calculating their urban water use objective. So we provide customized budgets monthly based on that customer's irrigable area. And so we've done a couple of massive efforts to not just physically map, but leverage a lot of digital tools like Google Maps and aerial imagery and all of those types of resources to really hone in on with high precision on not just the irrigable area for our potable sites, but for our recycled water sites. And we, over the last couple of years, have mapped all of those sites. We also have as Ben said, we utilize HydroPoint's ET data, which I'll show you a little bit more of as we get into the presentation. But we have 110 microclimates that we get daily ET for. And to be honest, like once you get your irrigable area collected, it's not it doesn't change much over time. It may change significantly at the customer level, but in terms of just overall irrigated, irrigable area, it stays relatively constant. I would say the thing that's going to impact your budget the most year over year, season over season is going to be ET. And so the rest of those things, for the most part, are constants. So you'll see like the 0.7 landscaping factor or the conversion factors, and we add that division of 748 to essentially create a billing unit conversion. So this may look familiar. Ben had something like this in the previous presentation. These are the 110 1-kilometer grid zones that overlay the district's service area. And so basically what we use this for is anybody that's within one of these individual grids will get a certain amount of ET on their bill. Some of the interesting things that you'll see in here is that we've actually taken this and color coded it. So, and you can see down there, it says ET factor, but what it really is annual inches. And something interesting about the district service area is that we are not on the coast, but we have a pretty strong coastal influence. We serve all the way down to Dana Point in the southwest, and we go all the way up to Mission Viejo in the northeast. And so what you can see, this was actually you can see the date range on here. It's October 2024 or 2022 to this October. We had in the lowest area in Dana Point about 20 to 25 inches total of ET in our service area, all the way up to, you can't see that dark red on there, but it's about 45 to 50 inches up in the Mission Viejo area. So we're in this really interesting space where we have a huge range of ET annually from our customers in the south and also to our customers in the northeast. And so we needed, in order to provide customers with the most accurate billing information, because you really don't want to mess with billing data. You want to make sure you're giving somebody science-based, as factual as you can, information to base their bill on. We ended up selecting HydroPoint and using this data to provide to customers, and then to help them track that information, because day over day, we've got irrigators out in the field that are utilizing ET sources to help them manage landscapes so that way they can comply or be within their water budget on a monthly basis. So we had to give them some type of information so that way they could continue to track. So what you're actually looking at here in this color-coded map is an application that our data science team built in our Shiny app that is available to the public. I actually listed the link right here. So our irrigators can go on our website. They can put in a date range of, the beginning of the month to the end of the month, or an estimated billing period, and they can look and see what ET was. So that way they can help manage, or it'll help them manage the water application that they have in whatever area they're in, whether they're serving Mission Viejo or Laguna Niguel or Laguna Hills. But we find this to be a super helpful application, not just for customers, but also for billing. So the next thing is our irrigable area. This is our irrigable area across the district. As I mentioned, we've taken a lot of time to map all of our meter service areas. So basically any place where water is being applied to irrigation and it's being served by a district meter. We've been able to identify that by getting we've got 4-band aerial imagery, had that converted to a landscape classification layer, and then kind of cookie cut that out with the meter service area map that we've put together. So we've got a pretty good understanding of where irrigable, irrigated, and irrigable, not irrigated is located throughout the service area. And we didn't really have to look at it at the scale before until we started having conversations about the urban water use objective. And it's really, it's been interesting, at least in terms of internal conversations, because if you take a look at this map, you'll notice in the western portion of our service area, there's a big blob of vanilla, and there's not a lot of landscape area that is being irrigated in that area. And so, you know, we started to kind of look at, well, you know, if we looked at ET as an average for a whole service area, you know, is that really going to be reflective of where irrigation is being applied? Or should we try to find a way to look at ET for our service area using weighted values based on where the water is actually being applied? And so that's where a lot of all these data sets have really come into play and been very helpful, because that little blob right there is actually the Aliso and Woods Canyon area. And if I go back to the previous slide, you can see it's a cooler area in our service area. So if that was included in some type of just general average for the service area, it would act to artificially pull down the total ET for the service area. And so I'm going to get to that. Mona Bina's done a lot of really in the weeds analysis for us to do some weighted averages and just do some comparisons, but we'll get to that. But first I just kind of wanted to talk through that process. So being a water budget based rate agency who has been delivering water budgets now for 12 years, you know, we're very familiar with the billing level of ET. You know, and that's one of the reasons that we selected HydroPoint. We knew that we could get pretty good data all across our service area, get it on a daily basis, be able to push it out through the billing process. But also over time, we've really seen that there's been a lot of, you know, like weather-based irrigation controllers really at the customer, at the home, or at the parcel level, where folks are starting to now use weather-based irrigation controllers. And you know, and then we'll have conversations with them about the data sources that they're choosing for their weather-based irrigation controller, and helping them try to find a weather source that aligns best with either our billing data or something that's reflective of the actual weather around their home. One thing that we have found over the last, I guess, 5 to 7 years is that as we've been pushing out a lot of these weather-based irrigation controllers, that the reference ET is really based on like cold weather turf. And we've been running, we've been running direct installation native plant programs for quite some time, as well as really promoting conversions of turf to more drought tolerant Mediterranean California native plants. And if you look at the water needs profile of a Mediterranean plant compared to a cold weather turf, you know, this is where you're starting to get into these weather-based irrigation controllers, and all they really have is reference ET for cold weather turf. And so I've seen a lot of innovation coming out of some of the WIBIC providers looking for ways to introduce new reference ET that better mirrors like watering needs of Mediterranean style plants, which would cover primarily like California and some of the other plants that we're asking customers to install. But that's one thing that got us starting to look at different levels of ET. Additionally, we've also seen some weather-based irrigation controllers partnering up with weather stations. And if you've got, you know, one controller installed here and it's running off a more general weather source, and one controller installed here and it's running off of the weather station that they installed, when rain clouds pass through, you know, is the one person over here with the weather station, is their system going to shut off more accurately than the one that's from the more general weather station? And we've had conversations about that. You know, but then also now we have to look at the district level, like the ET that the district is going to need to compile for purposes of complying with the urban water use objective. And so we have kind of gone through this thought process of, you know, how do we compare these different levels where ET is needed, you know, at like the home level, the landscape level for billing purposes, and then again at the district level. And how do we align those things? And how do we have conversations with our customers about like why we choose different sources and of data? And so that's what having this internal conversation is what really kicked off some of what you're going to hear in just a minute. So So because we are really focusing on complying with the urban water use objective, I'll focus mostly on kind of the district scale ET data. So we did a deep dive on a lot of the different sources that could be potentially used for the district, just for points of comparison. And there's no shortage of them out there. There's quite a bit. As you heard from some of the previous speakers, some of them are more geared toward ag, or there's maybe some spatial gaps or things like that that some of them may encounter. But as all of these new sources come online, that's why it's kind of we're doing our due diligence to evaluate them periodically and make sure that we're still making the best choices for the district and for customers. But if you as an agency are going to go through and do this for yourself, here's just some considerations that we've worked through that I would like to share. So first of all, I say there's no source of truth, but what that really means is that it's like Common Core math. I was going to share this example. Like 10 years ago, I used to work in a school garden program, and we had 3 teams of kids. They built a raised bed, and the teacher was like, I'm going to use this as a laboratory. And she told the kids, I want you guys to measure the volume of this raised bed. And so the kids, there was 3 different measuring instruments. There was, I think, like a laser level, a ruler, and then a measuring tape. And when they were all done, the kids had done they did their measurements, they looked at the volume, and then they looked at each other and they said, well, I got this. And the other one said, well, I got this. And then the other one said, well, I got this. and they looked at the teacher and they said, well, what's the answer? And she said, I don't know. And so it always reminds me of that particular scenario, because it all comes down to your instrumentation, how you calculate it, your methodology. Like somebody's going to come up with one number, and another approach, a modeled approach or an interpolated approach, is going to come up with another. I think, as you've heard the previous speakers, like over time, the Penman-Monteith equation has really evolved to be kind of the gold standard in this area. But there's other methods. I mean, but that is the gold standard. But in terms of like calculating on a spatial scale, like whether you're going to use interpolation or modeled data. So just something to think about as you're kind of going through and evaluating data sources for your water budgets. Another thing that I would mention is, like, as was previously mentioned, like there's some data source limitations, specifically looking at like the number and the location of data collectors. I've created a couple of images that we wanted to share. So on the left, these are CIMA station locations that you're going to find in Southern California. And over on the left, that's kind of generally where those stations are located. But on the right, you'll see an outline of Molten Miguel's service area and where the 3 nearest CIMA stations are located. And so CIMAS, or the spatial CIMAS, uses the interpolated values. And so one of the challenges that we've found in trying to provide the most accurate billing level ET is with having those 3 stations located in more interior locations, we're not really able to get a great estimate on what home water budgets should be for the folks that live near the coast in our service area. And then, so I wanted to create kind of a side-by-side comparison. When we were looking at like our HydroPoint data, we were finding that there was big swings in the difference between what we could find in HydroPoint versus what we would find with CIMA station data. And the nice thing about looking at the HydroPoint data is you can see that there truly is a coastal influence, and we know that that is prevalent. And so the district decided to go more with the HydroPoint data, so that way we could provide what we feel is the most accurate data available. The challenge that we also face with this, though, is that it is a proprietary approach. There's not the transparency that you would get maybe by having a public source of data. But as I think Ben said, that they have calibrated machines where they're testing and trying to get within 2% accuracy of those weather stations on the ground. And so you just kind of have to trust in the process. And so then the other thing I would say, if you're looking to explore data sources for your agency, is looking at data reliability One of the things that we needed was daily delivery of ET data, as well as level of service and responsiveness, because as a water budget based agency, we got to get that bill out. We can't put in an email and hope that somebody gets back to us for, within 7 days. We got to get that. We need to have that responsiveness within 24 hours. So that way billing isn't delayed and it doesn't delay future billing processes. And so that's those are pretty key things when you're looking to identify these sources. So now I'm going to turn it over to Mona Bina. She has been really key at looking at, as I mentioned earlier, like the data for our service area coming from HydroPoint, and then overlaying a lot of that spatial data to see like whether a straight average of ET across our service area or is going to be how that would put the district, or how that would position the district in terms of compliance with the urban water use objective, or whether we should be looking at more weighted average methodologies, which better reflect where our landscape actually is. And so I'll go ahead and turn it over to Mona Bina.
Thank you, Lindsay. I can share my screen. You
have it shared, Mona Bina. If you just want to tell me to advance the slide, I can.
Okay, yeah, okay, awesome. So I won't go dive deep into the spatial CIMMYTS and HydroPoint, because all our experts have talked about the methodology that goes into deriving the ET values. So I'll probably just go straight into the analysis. So maybe Lindsay, if you can go ahead 2 slides, and I want to go to the map where it shows the land use classification. And then, so one more slide, please. And the next one, yeah, there we go. We, as Lindsay and Ben mentioned earlier, that we use HydroPoint data, and we are trying to dive into different methodology to answer the question, what kind of methodology is the right way to derive the ET. As Ben showed in his presentation, within a zip code area, there can be over 250% variation. So we cannot take it is not recommended to take a straight average of the ET, because as you can see, there will be some places where there is more irrigable area, whereas there are other places where there is no irrigation at all. So what we did in the analysis is we followed 2 methods. One is weighting by irrigable area. So wherever there was more higher irrigable area, we added more weights to those microzones. We have 111 microzones in Molten Niguel service area. And the weights were basically, we calculated the total irrigable area in the entire district. And for each microzone, we did a percentage of what percentage of irrigable area is in that microzone. So each microzone got that weight. And we weighted the ET based on we calculated the weighted average based on those weights. So we definitely saw that showed a difference in the values when we take just a straight average, not considering the distribution of the irrigable area. And so the number was not same. Same for weighting by meter count. So there are some microzones in our service area where we have higher meter counts. There are some where there are not so many meters in those microzones. So if we take the same ET values for all the microzones, it won't be we won't be doing justice, because then there are some microzones where there's no hardly any meters, whereas there are some microzones is it's very densely populated. So we did the same kind of approach. We provided the weights to the microzones with the meter count. So wherever there was higher meter counts, it got a higher weight. And the approach was similar. We took a percentage, we calculated the total number of meters, and for every microzone, we calculated what percentage of the ET is in that what percentage of the meters are in that microzone. So the results showed us that ET was much higher, but the irrigated area was more. And ET was also much higher, but the meter count was more. So we came up with that analysis, and we are actually working on that analysis still. We want to use spatial CIMMYS data and do similar kind of analysis and kind of validate our methodology with multiple data sources. So as Lindsay mentioned, like it is worth diving into different data sources and using different methodology to kind of validate like this is the approach that we should go with. So that's what we are trying to do right now. So we want to extend this analysis a little bit more with spatial CIMMYS data and see if we are kind of seeing any differences in the weighting approach. So yeah, that's all I had. I just wanted to dive deeper into the analysis because we have heard a lot about our experts talk about the spatial CIMMYS, HydroPoint, and other ET data sources. So with that, I don't know, maybe Kim, I can give it back to you.
Absolutely. Thank you all so much. This was really informative. I know I got a ton out of it, and helped answer a lot of the questions that I had for the work that we're doing here at the CADC. And we've got some questions for you guys. So what I'd like to do is I'm going to start with the question in the Q&A, and then I'll go to the questions that are in chat. So our first question is for Michaela, and it is from Lauren Steely. Hey, Lauren. Can you comment on the general funding situation for CIMMYS and what the outlook is for expanding the network of stations, especially in the urban areas? And does DWR have any plans to update the IPA to address the current limitations? Thanks.
Thank you for that question. Can you explain what you mean by IPA?
Yeah, I'm gonna let Lauren, let's see if I can.
Looks like she meant API.
Yeah, I think the question was API, Michaela, and they were
Oh, okay.
the user interface for spatial CIMMYS.
Yeah, to just give you some historical background, CIMMYS, I said, started in around 1982, and formally DWR took control of the program in 1985. And to my surprise, the budgeting issue for CIMMYS has not improved all these years, despite the fact that now we have more stations, so we have remotely sensitive graded ETO information and all of that. Only about last year we got some VCP, and we got, I think, one additional position. But if we have to expand more, we're gonna need more staffing. We're gonna need more funding to buy equipment, and we need more resources to maintain the stations properly. I think I can answer your question as well for us along this line. CIMMYS is good when it is working according to the design. The design is you have to have a reference surface which is fully evaporating, fully transpiring, not short of water. And there is a reason for that. When that surface is evaporating, there is what we call a boundary layer formed within a certain height above the surface. Only if you measure these things within that boundary layer, your data is accurate. Otherwise, there will be some wind and the temperature crawling in from the surrounding dry areas, and your estimate is way wrong, or in most cases will be very high. So it needs to be maintained well, and we need more resources for that. And we are doing our best to get more resources, unless users can support us in doing that and getting that needed information. There were many legislation, by the way, that were enacted saying that CIMMYS data should be used, and the additional one is the fact that now more agencies need to do the reporting using CIMMYS data. but if the CIMS data is not everywhere, and if it is not to the quality that is needed, users will be affected. So I think it would take an effort by all of us together to get the needed support. It's not only for urban, by the way. Ag agencies and the ag users are also using this information. Actually, it was designed for agricultural purposes. So I think more is needed to get to the point where we want to be.
Thank you. And can you talk a little bit about any plans to update the API?
Yeah, there is a plan to update the entire CIMS system, not only API, and we call it CIMS Phase 3. The new phase is to improve the flow of data and information all the way from the field stations and all the way from the satellite capturing and to our databases and ultimately to back to the users. And we have just started that process with a company here in Sacramento. So I don't know how long it will take. Maybe it could be maybe 2 years or maybe 3, but there will be an improvement in the API. But it is available. It is providing service right now. The API is working fine, but I think it can be improved, and we're working on that.
Great, thank you. So we have a few more questions for you. One of them was about resolution, and I think you answered that in the chat, but if you can just talk about the calcimeter resolution.
Yeah, that calcimeter model, because we are using the PRISM data from Oregon State, as I said, for precipitation, when they designed the calcimeter calculation, they upscaled the spatial CIMS so that it can fit into that PRISM output of precipitation. So it is at 4-kilometer resolution, but ultimately what we provide to the users is just a summary at the water agency level. You get the summarized output from the calcimeter model.
Great, thank you. Couple of other questions for you. I think you answered these in the chat as well, but the calcimeter data that is available in its raw format for agencies already. Is that correct?
No, it's
not.
Just the summary that is available.
Just the summary. Okay.
Yeah.
Do you have plans to provide raw format data?
Because of the size of the data, we don't intend to keep that and make it available, but maybe for future years as we get more resources, that is doable.
Okay.
But no, we're not planning to do that immediately. No.
Okay. And then for spatial CIMS, do you account for elevation, temperature, and other factors that impact ETA?
Yes, for the interpolated values. Like again, the solar radiation comes from the satellite. We did the testing for many, many years. It is as accurate as it can be. And then the remaining ones, temperature, humidity, and the wind speed, we are interpolating, especially for temperature and humidity. When we do the interpolation, we account the elevation using the lapse rate adjustment. So yeah, it is considered.
And then how often is the LAM data going to be provided?
Yeah, the legislation when it came out, it didn't specify just provide one-time data. That's what we did. There were resources assigned to that, and we completed that work. But in our recommendations to the water board, we kind of recommended at least we need to do this once every 5 years. We don't have resources now for that, and our hope is maybe this will be part of the regulation, which would encourage the legislators to probably assign resources. Again, this is one of the areas we can work together because you cannot use the same data from 2018 imagery for most agencies and the 2020 for some of the agencies. You cannot use the same area going forward as the reporting is every year. So I think it needs to be updated. So, but that was our position and our recommendation.
Great, thank you. And then there was mention of how the weather stations are maintained, and if, you know, what kind of support is needed to help make sure that those are maintained on private property.
Yes, the maintenance is a key, as I mentioned earlier, because if it is not well maintained, the values that we read at that station height is not going to be from that grass surface as expected. It will be from the surrounding areas. In most cases, kind of inflating the ET estimation at that point. So the maintenance that is needed, it has to be regularly irrigated, it has to be regularly mowed. And if there are some animals grazing in the area, there has to be some kind of a fencing to keep the animals away from instrumentation. And this can be arranged. We have 4 regional offices. We have staff who are assigned to CIMIS that go out to the field and they do some of the more difficult maintenance things, such as replacing sensors and so on. What we expect from agencies or what we call cooperators is to do the the irrigation system and in some cases the mowing, but arrangements can be made again. DWR also can help with some of these activities. The key for us now is to find that suitable property or land on which the stations stand. Once we install it, it has to maintain that status. Otherwise, if irrigation is cut back at one point and the grass dries, we are turning it into what we call non-ETO. ETO is not calculated because it's not satisfying the reference surface condition at that point.
Yeah, and yeah, go ahead, Forrest.
That can be one of the biggest sources of error, right? Is if, especially during a drought, if someone stops watering the grass, then of course you no longer have a reference surface, and you have hotter, drier conditions around that CIMIS station, which can lead to some pretty important biases in the reference CT data. So for agencies that are relying on the CIMIS data, taking the time to check in with landowners and underscore the importance of making sure the grass is well maintained and instrumentation is checked on and maintained is really important, and the simplest thing that can be done to increase the overall accuracy and quality and reliability of the data.
So Forrest and Ben, yeah, if you're getting, if you're pulling the CIMIS data and you're seeing zero reads or reads that are, seem like anomalies, are you sharing that with CIMIS to let them know there might be an issue?
On any given day, there may be a single lack of data, so we don't really report on a missing day. But if we see a pattern, like if we don't see solar radiation or temperature sensing for weeks on end, we're going to notify CIMIS and let them know. Sometimes we don't know who maintains the station. So if it's the city of Roanoke Park or Santa Rosa, or if it's, DWS themselves, it'd probably be good for us to get a list of the stations and who the maintainers are so that we could improve our partnership and communication ability with CIMIS. Be happy to do that.
Yeah, zero reads and no data, those are easy, right? We can flag and mask those and remove those, and CIMIS does a nice job with the QA/QC and flagging those types of issues. What's harder to catch is a case where the reference surface the water's been cut back and then maybe cut back a little more and then turned off, right, for a while. And then instead of having a nice, well-watered grass, you've got dead, short, patchy grass or even bare dirt. And those types of gradual degradation of the reference surfaces, those are harder to catch and flag until someone actually goes out and looks. So we've actually been working with DWR on the CIMIS program and conducting a historic evaluation of all of the sites, and then working with DWR to try to understand how that might impact or lead to potential biases in the data.
Yeah, if I can quickly add on to that, Forrest reminded me, the CIMIS has a quality control system in place that is automatic, by the way, and there are flags that go with CIMIS data. Most users do not pay attention to that, but what it is saying is it uses some kind of statistics to show how many standard deviation that data is from the mean for specific data. There are different QA/QC things, but what I would encourage folks to do, this is not required for submitting the reporting on water use objective. But we have done that part for you. But generally, so if you're just using to schedule your irrigation system, for example, please pay attention to the QAQC so that if it is extremely out of range, you might want to use an alternative method. We always pay attention when there is so much flagging, we fix or we replace the sensors. But in the meantime, the data that has already been collected would remain the same. We don't change numbers, but we do flagging. So it is good to pay attention to those.
Thanks. So Lindsay and Mobina, I think you got a couple of questions. The first one is, have you found that growers are receptive to using the HydroPoint ET data for their irrigation scheduling?
I can tackle that one real quick. We don't really have, we're like 100% urban. So we don't have a lot of growers per se, but we do grow a lot of like grass and urban greenery. And a lot of our irrigators have, they utilize the weather track system, which uses HydroPoint data. And so in those cases, because they're utilizing a similar data set from what we bill on, they're usually pretty in alignment with whatever the water budget would be on a monthly basis.
And then you mentioned that ETO values may be more suitable for cold season grasses than native landscaping. And is this something you could just be addressed through adjusting the plant landscape factor for each customer?
We probably, I mean, just the level of effort that it would take to adjust that would be challenging. I think the other thing too is there's just really not, it would also be dependent on the ET data source. We would have to have, and if you'll permit me, I'd like to just share my screen real quick just to show you why. Okay, because the reference ET is really important, and I just have this to share because a lot of times with that reference crop, you're looking at a plant water needs and transpiration processes that really mirror this kind of a schedule. Even with some of our drought tolerant plants, it's going to go up in the summer. But when you're talking about California natives like that come from these summer dry Mediterranean climates, we're really looking more at a schedule that is almost inverted. And if I added the precipitation line in from like our average precipitation in Southern California, you can see that these things are really much more in alignment. And so that's why it's not really just a matter of minimizing it by the WUCAL's like plant factor of like 0.1 or 0.2, that reference ET, that chart or that like trend line is going to look different over the year because of, just because they're different plant types and they have different transpiration rates. I hope that was illustrative.
Yeah, it was.
Okay.
Thank you. Any other last questions? You can put it in your chat, you can raise your hand. Awesome. Well, this has been fantastic. I have learned so much. We will make this presentation and the recording available, hopefully, if not this afternoon, by tomorrow, and you'll get an email reminder letting you know that it's there for you. I want to just thank you all again, speakers. You've been fantastic. Thank all of our attendees for showing up today. And I just wanted to share a couple of other things that we have going on at the CADC, and we hope you'll join us for more goodies like this webinar. Just so you know, we're working on a new service for urban water use objective compliance. So a couple of things that we're looking at for members and non-members is helping you classify your CII customers, help you identify your mixed use meters if you've got AMI data, and then also helping you to do landscape area measurements for all of your CII customers. So those are some things that we're working on right now, and we'll be sure to share that as that gets developed. Just wanted to highlight some of the projects that we've done for members. So this is part of what we call our Insight project. So members can tap us and our data scientists to do some customized projects that fit their specific needs. So this all relates to water use objective, but we've been doing this, this new service that we're launching is really based on some work that we've done for a few of our members, like Montecito Water District, where we looked at their CII objective, came up with that, helped them start classifying their customers, identifying their mixed use meters that could potentially turn into dedicated irrigation meters. In the past, what we did with the residential land data is we did some an analysis to make sure it was accurate and provide any feedback to help you get that data corrected. We'll be doing that again for the CII land data when that becomes available. And a project I'm really excited to share is a joint project with San Diego County Water Authority and CalWEP. And we're working with a few agencies in the authorities area to scope out their CII mixed use meters and really develop a roadmap for how to identify those. And then, do the area landscape measurements for those CII customers. So we're going to have that guidebook available in the spring, and maybe at a next, one of our other webinars, we'll be able to go into how to do that yourselves. So our next workshop is actually, it's January 25th, not the 26th. It'll be from 1 to 3. We are working on ideas. So if you have any, please let us know. And we are also working on our 2024 California Water Data Summit. So look out for details for both of those. And with that, we're going to wrap up today's webinar. Thank you all so much. And look out for an email with the links. So thank you all again. It's been fantastic.